In this video, we're going to construct and interpret confidence intervals for a population mean when sigma is known. I'll be using the calculator to help me do that. So I have that open over here. For the sample statistic, which level of confidence would produce the widest confidence interval, that would be the biggest level of confidence. So that would be 99 because the level of confidence increases, Z increases, and that's going to increase our margin of error. Which will increase the width of the confidence interval. Since our confidence interval is x bar minus e to x bar plus e, and e is equal to z sub c times sigma divided by the square root of n. As c increases, z sub c increases, which makes this numerator bigger, which makes the error bigger, which makes the confidence interval wider. All right. Let's go ahead and go to stat tests. And then number 7 is our Z interval. We're going to put data in here. And we're going to put stats in. Data would be if we had a list. So we're going to start with sigma is 0.9. And we have x bar is 9.9. And we have n is equal to 58. And our level of confidence is 95%. And we're going to round to 2 decimal places, so that's 9.67. And that's 10.13. Let's look at our next one. Let's construct the confidence interval for the population mean when sigma is known, and sigma is 10.0. X bar is 16.2. N is 45. And C is 0.98. And 1 decimal place here, so 12.7 to 19.7. A random sample of 50 business days. Gold prices at a mean value. Actually, they give you everything to get the confidence interval. There's the confidence interval. Does it seem possible that the population mean could equal the sample mean exactly? It would be very unlikely because the margin of error is large enough that the odds of selecting an exact value is very low. So there we go. 5 from the sample here with this data that produces that confidence interval. Does it seem likely that the population mean could be greater than 34? Yes, because 34 is smaller than the left-hand bound. So there we go. If all other quantities remain the same, how does the indicated change affect the width of the confidence interval? So I already showed you that formula before that has to do with the margin of error. That's z sub c sigma over the square root of n. So these two things, if they get bigger, will make the error bigger, will make the confidence interval wider. As n gets bigger, it makes the denominator bigger, which makes the error smaller, which makes the confidence interval narrower. So if I increase the level of confidence, the confidence interval will widen. If I increase the sample size n, it's going to narrow. If I increase the standard deviation here, it will widen. All right, and I think that's it for this video. Yes, it is. We'll come back next time and keep talking more about 6.1. See you for the next video.